Hello, friends. I hope everybody of you are doing well here. Today, we're going to learn about overfitting in machine learning. What is overfitting? Overfitting is basically a situation where your model trains the data too well. It happens when model learns the detail as well as the noise, and to that extent that it affects the data negatively. So yeah, it's basically when it calls the value which are supposed to be false also true, which is the noise. Uh, so that's what overfitting is. So basically, overfitting and underfitting are the main causes of the poor performance of your model here. So it basically happens on models which are non-parametric and non-linear, or you could say that with the models which have more flexibility. Now you might say which models have more flexibility there. So flexibility basically is the measure of the fit of the model. So for example, if you have a linear model there, it's basically a graph where a straight line goes through. So for example, take a situation where you have two classes and you want to classify them. So basically what you do here is you if it's a linear model, you bring a straight line out there, and uh, the classes are all jumbled up in the graph, right? So if it's a straight line, it's a rigid model, so it does not give into other parameters out there. It's just a straight line. It doesn't care if some points of class 1 are on this side or on one side and some points of class 2 are on other side. So that's a linear model. It's a non-flexible model. And other models on the other side, there are flexible models. So these kind of models are, they can do some adjustments in such a way that they take more and more of class 1 data on one side and more of class 2 data on other side. So basically the line that separates the both classes is not straight in this situation there. So this can sometimes lead to overfitting of data, meaning that you know this model, flexible models, sometimes they do work well on the training data sets, but when you try to use them on test data sets, they do not work very well there. So that's basically what overfitting is in a nutshell. So I will actually learn more about while by doing it. So let's make a small presentation here. So here I have basically I have a small customer churn data set. You can take any data set, but I have taken this one customer churn data set. I've just loaded this data set here and just clean the data a bit, and now what we will do is we will actually try to do right. So let me just right. What we'll do is we'll make down in the sample data. We'll actually do some. I'll actually show you how this thing actually works. Okay, so let me. So I have. So basically, what I have done is I've just taken in the data, cleaned it a bit, and that's it. And then I just made some did some encoding here on the dummies function. So all right, let's all right. So for the first step would be here to create 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 train and test data. Okay, so for this we already know the sklearn library that is used for it. Model selection, import train underscore test underscore split. This is actually what I like the most about Google Colab. You don't have to do a lot of work here, basically. Yeah, so x train comma x test, y train, y test. That goes to train underscore test underscore split, and whatever you have it in here. So here I have it as x. So basically, what I've also done here is I have converted them to uh, features and target column. Okay, so x comma y, and I just want the test size to be so 20% target variable and 80% training variable. So training data is 80% and testing data is 20%. That's 0.2. And there's also a random state, just to induce a state of randomness here, so that it doesn't all come in this as the same. You can I take it 101. You can take it any number. I also shuffle the data here, and just so that doesn't give us any problems. Stratify. Okay, that's it. Or they are ready now. Now what we'll do here is I'll take a, so as I said before, let's take a flexible model there. So I'll take a decision tree model there, and let's see how that works out. So first so basically what the idea here is, you basically I take increasing number of trees there. So in decision trees, I'll take increasing number of trees, and then I'll show you how the number of, if basically, what we think is, if we increase the number of trees, then you will get a good model, but that's not always the case there, and I'll show you how it works here. All right. So I'll just make a loop here. Range 1. So these are, basically trees from 1 to 21. Okay, so now what I'll do here is I'm importing the model. I won't say the model, it's just a class. Decision tree. Oh, did I get the spelling wrong? Decision. Yep, that's the right one. Decision tree classifier. Oh, yep, I think I got what I got it. Yes, forgot to put an N here. Then from let's take dot metrics import accuracy score. I'll actually show you how accuracy ranges with the number of trees. Okay, I'll make some list. I'll make an empty list here, training scores and test scores. Okay, sorry, it's a bit messy there. Alright, so now let's go. I'll make a loop for I in values. I'll first, write all the whole model and then I'll, explain it a bit here. It's pretty self-explanatory, but yep, let's go. Alright, so, alright, let's get the model up and running. This entry classifier. And there's actually a thing called max depth in here, which you put it as I. So max depth is basically the number of trees that you want in there, the number of trees that you want your model to, build. Right. So now we got a model there. We fit it on the trading data. It's not big one, small. X train, Y train. Then you train model, predict the model, predict. X underscore train, train. This is all pretty self-explanatory, but yeah, it's getting the accuracy score here for the model which I have built right now. Okay. Scores. So we also have to append them, right? Train. Okay, I've appended that. And also this is the train data set. Now we do the same for the test data set. Okay, let's see. I'll just copy them off. Why write all that thing again? Oh, no. Copy selection. Okay, let's paste it off here. Yeah, that's better, isn't it? And just put a test in here. Test, wherever there's, yep, you put test all over there. Test. Okay. Then you have the test scores. There also it will come test. Alright. And just, this is just to summarize things here. Yeah, we can always, alright. Say, comma, train, person, 3F, comma, this is it, what's the test? Same thing, yep. Person, think we're done here. So what do you want to put in there? So I want to put in these values. So this first one, so the first value for ampersand d, it would be I. Then the training accuracy, then testing accuracy. Okay, so this is my fingers crossed. Okay, here we go. Oh yeah, this is supposed to be both test. Yeah, that's how we learn. Okay, okay, okay. There you go. Test. Please run now. Ah, there we go. There we go. Now, what I'm gonna do is I'm just gonna to make it to make you understand better. I'm gonna get you a graph here. Okay. First gotta import matplotlib. Okay. Then you see, as I said, it's better. Values. Values are just these things. It's just the low range there. All right. I'll get the train scores first. All right. Get the label equal to train so that y'all know it very well. I'll just copy it off and do the same thing for the test. Okay. Test. Okay, okay, alright. Test here also. Alright, and what is next? Oh, I made a big mistake. Madam. Alright, so also plot dot legend. We also need that. Plot dot show. Here you go. So, alright, what do you see from here? Just pause the video and check this graph out for a minute there. So, okay, so now let me zoom it a bit. Okay, so basically what you see is these are the accuracy scores, and the blue one is the test data set, and the orange one is the the blue one is the training data set, and the orange one is the test data set. So what you see here is at this point, basically it should be actually the opposite of it here, because the training data set accuracy just increases, goes on increasing, and this the test data set accuracy just decreases from here. So this is our optimal point, and after this, if we take any other points, or the trees, these are actually the trees which we are taking here, right? The I, that's the number of trees which we want our data set to make. If we go any more than that our model would be overfitting, and you would actually, the accuracy scores would decrease from here. So this is what overfitting is. So this is how you get an optimal points for it. There's actually a couple of ways which you can get the optimal points here. So one of them is a resampling technique. The best one would be the k-fold cross validation. You know, where you train and test your model k times on different subsets of the training data, and build an estimate of the performance. That's the best thing out there right now. And the other one is you hold back a validation data set here. The validation data set is, whenever you're splitting your data sets, you split it in three parts. The first part is, oops, sorry,